subtracting polynomials. This can be a little different. Well, this is very different than adding, because when you're adding two things, what you're doing is you're combining these two. They are coming together to meet together. That's why there is something called the associative property. Let me make sure I'm saying that right. Yeah, the associative property of addition says that 4 plus 3 is the same thing as 3 plus 4. It doesn't matter. But that rule, you can't do that with subtraction. If I have 4 minus 3, that is not the same as 3 minus 4. These answers are not the same. 4 minus 3 is a 1, and 3 minus 4 is a negative 1. Those two things are not the same, which means that you cannot just combine like terms. I cannot bring something from the right and move it and move these things together. They are not combining in that direction like that. So what happens with subtraction is what you have on the left side is what you have. Okay? For instance, this is what I have. This is what I take. You can't reverse that idea. So what's on the left is what you have. You take from what's on the right. Now, this whole idea starts to get a little confusing, especially when you're working with integers. For instance, let me throw up a math problem for you and let you take a look at that. What if I show you this? So you have a 4, and you're taking a negative. Uh-oh, isn't that a rule? Isn't that an integer rule where that says, hey, isn't that a give back? So isn't that really or technically this? You're going to say yes. So when it comes to subtraction, there is positives and there are negatives, and there are rules to subtracting negatives. So it can create a lot of confusion. So I want to show you a trick that I teach all of my students. And maybe you'll like this trick, okay? Now, this trick was taught to me, and I thought, you know what, I really enjoy that. I understand that. Let me see if I can get some students to like that. So let me show you what it says, okay? What it says is that if I have a subtraction problem, for instance, this one, I can change any subtraction problem to an addition problem. I can do that as long as I reverse the sign of everything behind that symbol. Let me show you what I mean. Right now, that is 4 minus positive 3. Now, if you're like, Baron, that's not a positive 3, that's a minus 3. I'm like, no, it's not. Here, let me do this. There we go. That is not a minus 3. That's actually minus a positive 3. So that's actually, if we're talking about how I teach, this is money minus money. This is not money minus debt. This is money minus money. Positive minus positive. That's why I'm left with positive 1. Money minus money. So let me show you the trick. The trick states this. You can change any addition or any subtraction problem to addition as long as you flip the sign of everything behind it. So what I'm going to do is I'm going to change this from subtraction to addition. But that positive 3 now has to become a negative 3. But I'm going to get the same answer. Look, 4 plus a negative 3, 1. Let's try it again. Because sometimes people are like, wow, I've never seen that. Look, I'm going to even make the first number a negative. Let's go negative 5 minus 4. And I'm going to say negative 4 this time. Let's go ahead and say that. Minus a negative 4. Now, let's go ahead and solve this so that you can see, well, whatever I get here, I'll get when I change the signs. So negative 5 minus a negative 4 is a give back. So that's really negative 5 plus 4. And negative 5 plus 4 is negative 1. Now, let's try it again. Let's go ahead and apply the little trick. Let's take a negative 5. And now instead of subtracting, we're going to add. And instead of it being a negative 4, it's now going to be a positive 4. Check it out. What is negative 5 plus 4? Negative 1. So this little trick helps. What it does is it definitely helps when you're dealing with polynomials because there's so many items up here that you're subtracting, and it can get quite confusing working with integers. So let's give this rule, this little trick, let's apply it over here. Here we go. So you notice that you're subtracting. I'm going to reverse it so now that I'm adding. Now, I can change that. I can do that as long as I reverse the sign of everything behind it. So this was a positive 2n squared. I'm going to change it to a negative 2n squared. This was a minus 3n to the third. We're going to change it to a plus 3n to the third. And now that it's addition, I can now just work on combining like terms. Oh, my spelling, sorry, combining like terms. And you don't have to worry about your integers or subtracting integers. You can just now say positives and negatives and positives and don't have to worry about anything. Okay, let's find the highest exponent. Hey, it's this one. Is there anything on the right to combine with? No. So I'm just going to make this first on my list. 3n to the 4th. Yay. Let's get rid of that. What's the next highest term? You can say, well, these n to the thirds. Yep. And what's up there? I have a positive 5n to the third and a positive 3n to the third. That means I have a positive 8n to the third. Yay! Get rid of those. I'll say what's left. Just this negative 2n squared. Yep. Now I'm going to show you most of the time on the GD test. The GD test, maybe we'll write it like this: plus a negative 2n squared. Now you'll say, well, Baron, couldn't I have said 3n to the power 4 plus 8n to the third minus 2n squared? And I'd say, yeah, writing both of these, it's the same. There's no difference. Adding a negative 2n is the same as subtracting a 2n squared. But the test tends to show negatives as a negative number. So you might have a tendency to see it as adding a negative 2n. But if it doesn't show it like that and it shows it as a minus 2n, just know that those two things are the same and they are no different. Let's try the trick one more time because sometimes it can get confusing and there's a lot of stuff going on. So let me go ahead and let's skip down to this one. Okay. So again, I'm subtracting. I want to change that to addition. I can do that as long as I reverse the signs, everything behind it. Okay. So let's go ahead and do that. Let's change this from subtraction to addition. Now, this is a positive 7 becomes a negative 7. This is a minus 10n becomes a plus 10n. This is a minus 14b squared. It becomes a plus 14b squared. Now, let's combine. Highest exponent, right there. So I want to go ahead and write that first. Notice it's a plus, so that's a positive 10v to the 4th. That's gone. What's next? Well, I see a negative 7v to the 3rd and a minus nv to the 3rd. Well, how many is that? That's negative 16 or minus 16v to the 3rds. See that? Subtract that. What's left? I have this positive 20v squared and this positive 14v squared. Is that the same thing as plus 34v squared? Yes. Yay! You've now learned a little trick.